For my math friends, a video on algebraic expressions with a focus on simplifying them and solving them if the variable is defined as a certain number. Okay, so first off, what are the parts of an algebraic expression? What is an algebraic expression? Well, this thing I've drawn in the little red box there is an example of an algebraic expression. Sometimes the term expression gets confused with the term equation, but basically you can see this is not an equation because there's no equal sign, okay? Now, realistically, and we'll explore this in a second, but it can equal something. It can have an answer. It can be equivalent to something. But when we don't express it with an equal sign, we don't call it an equation. We call it an expression. And so what are the parts of an algebraic expression? And they're labeled here in blue. So each of these little units, like the 4x and the 5 in this case, are referred to as terms, okay? So this expression has two terms. These terms are not like terms, or they are not alike. And so that's why they are distinct terms in this simplified expression, but we'll get to that later as well. The terms themselves, one of them contains the x, which is a variable, and that x is connected with a coefficient. And those two things are connected together. You can't separate out the 4 and use it in combination with the 5 or something. The 4 represents there are 4 of whatever x is, and x could be any number. And so you might say, well, why is that useful? And we'll look at ways that can be useful, for example. But you want to be able to substitute any number in for x so that the expression can have a different value depending on what x is equal to. So sometimes I say this expression is like a little computer. Your input is going to be whatever you put in for x, and your output is going to be whatever the whole expression is equal to. The final term, which is just the 5 naked with nothing attached to it there, is referred to as a constant, just a regular number. And I'll give you an example in a second what this might actually mean tangibly in real life. Okay, so upon introduction to algebraic expressions, lots of students ask, like, well, what does this mean? Like, this doesn't even look like math anymore. We have letters in there. Like, how is this math and how is it practical? Well, remember, math is like a model of something. And so this is also a model. And we're going to see that this is also potentially the start of something called a relationship. So we'll be able to graph it potentially, and we'll be able to show a relationship between whatever the input value x is, and then whatever the output value the whole equation is equal to. So you can imagine, for example, like I put here, imagine this represents that a farmer will pay you $5 for turning up to the berry patch, and then an extra $4 for every box of strawberries you pick. Okay, so, we could use this expression to show us how much money we will earn based on how many berries we pick. So, for example, if we pick 3 boxes, how much do we make? So if we pick 3 boxes, how much have we made? And you could pause the video and try and figure that out. If we pick 3, that basically means that x is going to be equal to 3. That's our little input. That's the variable. That's the thing that can theoretically equal anything. And so in this case, it's going to be assigned to how many boxes of berries we picked. So what we would do is we would do $4 times 3 boxes of berries plus the $5 he's going to give us just for turning up and being there. And so we're going to get $12 plus 5, and so we are going to earn $17. And so this is like the utilitarianism, or what's the usefulness of doing algebra or having an algebraic expression, is we could imagine or predict, using any input on how many boxes we're going to pick, exactly how much money we're going to make. And it's basically doing that through a model or relationship. What we've technically done when we substitute in the 3 for x is we've done something called solving. the expression. And so we need to learn how to solve expressions with efficiency, and also how to simplify expressions so that we can get them in this form if they are first presented to us in an uglier and more complex form. So let's work on that. So when we are simplifying expressions, there's basically one rule to it. And then from there we can look at, easier and more difficult ones. But the main rule is we group like terms together. And we can only process, meaning add and subtract, like terms to one another. So what are some examples of like terms? What do I mean? I mean like anything with an x, right? That would be a like term, and we would go ahead and group those together because we could process those. We could add them and subtract them together. Or it might be anything that does not have any variable attached to it at all, like these constants, these just numbers. Those are like terms. Or maybe in a different scenario, we won't probably get this far, but maybe it's like the y squared type variable, or it could be x squared, or it could be xy. Anything that has that same type of variable in the term, those are like terms. So for example, if we have an expression like this expression contains 4 different terms, right? It's got the 2x term, it's got plus 3, it's got the minus x term, and it's got the plus 5, okay? That's 4 distinct terms. Well, we can group these together as like terms and say, hey, we can combine that 2x and that minus x, okay? They're going to go together over here. And we can also combine that plus 3 and that plus 5. Those are constants, and they're going to go together over there. So we can rewrite this to make sure that we're comparing apples to apples and oranges to oranges. And we can say, all right, we can only add these together, and we can only add these together. Without having an actual value to sub in as x, we could not possibly do something like adding this and this together. We wouldn't know how to do that. It just wouldn't make sense to do that, okay? So instead, we only combine and process like terms, birds of a feather, apples and apples. So we take the 2x minus x, and just like you would, with regular numbers, if you have 2 of something and 1 of something, 2x minus x is equal to 1x, or just x, okay? Think of x as being anything else, and it might make some sense. So if x is 2, if you had 2 2's, and you subtracted 1 2, you would have 1 2 left, right? You would have x left, okay? Hopefully that makes some sense to you. And then we will do the constants, okay? So plus 3 plus 5 is equal to plus 8. So the simplified expression here would be x plus 8. Okay, here's one here. The expression is at the top. It's not simplified. So what we're going to do is we're going to first simplify it, and then we're going to solve it if x equaled 2. Okay, so let's simplify first. We can start by grouping like terms together. So we've got a 2x and a minus 7x. This brings up a very good point. Remember that, or maybe you don't remember, but I'm going to teach it to you for the first time, and hopefully you remember that if you have a, what do we call it? An operator is what it's technically called, but like a sign, like, a negative or a positive or whatever, that has to go with the number or with the term that it's attached to on the right, okay? So that stays with it. So in other words, like when you're grouping like terms together and simplifying, you're going to do 2x minus 7x, okay? That minus stays with the 7x. Then we're going to write the other stuff. So the other like terms are plus 4 and minus 1. So we're going to put them here, plus 4, minus 1. Organize our work well, and then we're going to process the like terms. 2x minus 7x is equal to minus 5x. And then we have plus 4 minus 1 as our other set of like terms, and that's going to equal plus 3. So our simplified expression is minus 5x plus 3. Now we're going to solve it if x is equal to minus 2. So we could solve it the simple way, first of all, using the simplified form, and then we'll just check our work using the more complex form up here, just to make sure we simplified it correctly. So all you do when you're solving is you do what's called a substitution. Okay, so you're going to substitute, just like any substitution. You think of that in basketball or something. You're going to substitute, or maybe a substitute teacher or whatever. It's like someone has left and someone else is coming in to do it. So we're going to substitute that number 2 in for x. So it becomes minus 5 times 2 plus 3. Minus 5 times 2, according to BEDMAS, you do that multiplication first, and that's minus 10. Now again, notice that I kept the operator with that number 5, okay? It's like this becomes linked together, the operator and the number. So it becomes minus 10, and then we're going to add 3 to that. Minus 10 plus 3, if you're keen on your integers, that's going to be minus 7. Okay, so let's try it with the big expression here, with the non-simplified expression, just to make sure we get the same answer, to show that those expressions are equivalent to one another. So 2 times, we're going to sub in 2 for x, so we're going to sub in 2 for x, 4 minus 1. We get 4 minus 14 plus 4 minus 1. Please tell me this whole thing is going to equal to minus 7. It's minus 14 plus 8 minus 1. That is equal to minus 7. Yes, sir. Okay? All right, something a little bit complicated which can come up in these expressions that we need to simplify and deal with is the application of what's called the distributive property. And so what we see here is that we can have a couple of terms in a bracket that we can't simplify. So if you examine like what's actually inside this bracket, according to BEDMAS, we would want to like do that first and simplify what's in the bracket, but we can't, because x and 3 are not like terms, so we can't process them together. We can't add them together. The best we can do is leave them as x plus 3, okay? So we're going to take this bracket situation and take the 2 that's multiplied by everything in the bracket and distribute that 2 through, okay? So what that means is we're going to multiply the 2 times the x, and then we're also going to multiply the 2 times the 3. So if we write this out, okay, step by step, when we multiply 2 times x, that's going to be 2x, and we multiply 2 times plus 3, that's going to be positive 6, okay? So we end up with this expression written like this, okay? Then we can group the like terms like we might not be expecting to do. So we have 4x and plus 2x. And then in terms of constants, we have plus 6 and minus 1. So we process that. We simplify that to 6x plus 5. There we go. We've simplified that using the distributive property to help us deal with this part here with the bracket. If I introduce 1 like you see here on the right hand side, there's an additional complication that I don't want you to trip up on, which is what if when you're about to do the distributive property for this part of what you have is a negative number out front, or sorry, just a negative out front. You know, the negatives and positives in this case are often called operators. So what if you just got a negative operator out there and nothing else? What do you do with that? How does that look? Well, what you do is you treat this as if it's a minus 1. So you want to distribute that minus 1 through those other 2 terms. So let me write this out in simplifying and you can see what we're doing. So we'd have 5x minus 7. Just rewrite those. Then you'd have minus 1 times 3x, which is minus 3x. And then you have minus 1 times minus 3. Remember, you want to keep the operator and the number together. So minus 1 times minus 3 is plus 3. So if we distribute that minus through that bracket, we get minus 3x plus 3. Then we're going to group the like terms together. So the x's, you're getting grouped together. And remember, the negative goes with it. And then the constants, they're getting grouped together. And these are one set of like terms, and that's another set of like terms. 5 minus 3 is 2x. Minus 7 plus 3 is minus 4. And so that one simplifies to 2x minus 4. And why not go one step farther and say solve these if x equals minus 2. So for this guy up here, it would be 6 times, oh, did I say minus 2? Just x equals 2. 6 times 2 plus 5, that's going to be 12 plus 5, 12 plus 5, which is going to be 17. And over here, if we solve this one, it is going to be 2 times 2 minus 4. That's going to be 4 minus 4. That's going to be 0.